This video will be looking at Chapter 10, Triangle Trigonometry. This is a continuation, but we're starting into Section 10.2 into trigonometric ratios. So specifically in this video we'll be looking at finding the values of trigonometric ratios and finding the angle when we're given the value of a trigonometric ratio. So for those of you who this was that last part of geometry or algebra 2 at the end of the year and your teacher didn't quite get to trigonometry or raced through trig at the very end, it's okay. I'm going to take this step by step and I'm going to make it to where you're going to get done with this unit and say to your friends, hey, I know how to do trigonometry now. So let's look at this, and first off, trigonometry or trig is just being able to label sides when given angles or given the lengths of sides using some easy to follow rules. We just need to really make sure that before we get started that we understand what the different parts of the triangle and what those rules are set up, how those rules are set up, so that we can define the different parts later on and when we're using them. So when we're looking at an angle, and I want you to notice one thing that's really important is that how we are labeling the triangle. So the triangle is labeled with capital letters A, B, and C are at the angles, and those capital letters A, B, and C, I'll erase that so you can go back and see them, are talking about the angles inside. So this is angle A down here, angle B, and angle C is a right angle. Now, the side exactly opposite, and so I want you to think of this as if you're standing on angle A, big A, the perspective, you're looking across the triangle, and across the triangle, the side opposite of the angle A is little a. And the same can be said for if you're standing on the angle big B, then you're looking across at the leg little b. This is a side called little b. Now, if you're standing on angle C, which is a special angle, and this is in the standard form, triangle is set up in the standard form with the right angle being at the bottom right, and we covered this a couple videos ago. You can go back and look at it. This really helps, especially when working with trigonometry. When you're standing on angle C, you look across and you don't see a side, you see the hypotenuse. And so we've used this word constantly, but we really want to make sure that in these cases that we are definitely not calling C a leg or a side. It is the hypotenuse. And this is going to be important as we're talking about sine, cosine, and tangent. And so remember, the side across from big A, from angle big A is little a, the side across from big B, angle B is little b, and the side across from the 90-degree angle of big C is the hypotenuse little c. And we also use this in doing the Pythagorean theorem. So this is that's probably a bit of a review, and hopefully I didn't overdo it, but I really want to make sure that it's clear as we start to get into talking about sine and what our sides are. So when we're looking at, in this case, angle B, we're saying, okay, looking at from angle B, that the side next to it is A, because that's the side that's next to it. The side across from it is going to be little b. All right, and of course we have our hypotenuse over here. And so this is a way to be able to describe from that perspective of looking at angle B or big B. And again, the hypotenuse is never considered to be an adjacent side or an opposite side or a leg of the triangle. Okay, it is the hypotenuse. So when we're talking about the terms adjacent side, opposite side, we're talking about use from the perspective of the angle, big B or little big B or big A, and we're only using these terms when we're talking about right triangles. Okay. So here's another thing that I recommend you writing down and putting into your notes for the test and for the final exam. Some people might have it memorized already. The term is SOHCAHTOA, and we will go over this as we cover the different trigonometric ratios that we're going to describe, being sine, cosine, and tangent, and what SOHCAHTOA means. So let's start with sine. And so looking at the right triangle, it says it's the triangle, but we want to make sure that these are right triangles when we're using these ratios. The sine ratio is abbreviated with the word or with the letters SIN, which is pronounced sine, not sin. And so sine is defined as following. And so notice we're going to look. It's got two definitions: sine A and sine B. With sine A, it is the side opposite of angle A. So the side opposite of angle A, whatever that length is, over the hypotenuse, or whatever that length is. Just two numbers. So A over little c. And you don't have to memorize these because you'll have them written down. Sine B, again, now we're going to look at, this is a different perspective, because now we're going from sine B, we're not looking at from sine from this angle here, we're going to look at it from B, which I have covered up here, sorry about that, from the perspective of standing on B, and it's the side opposite big B, which is going to be little b, and it is the hypotenuse right here. And so right there. So it's going to be little b over little c. Basically, sine is the opposite over hypotenuse. So opposite over hypotenuse. Opposite over hypotenuse. Okay? So that's where the abbreviation SO comes from. Sine, opposite over hypotenuse. Okay? Let's go ahead and put this to practical use on a problem. Go ahead, and if you want to take a stab at trying to figure this out, go ahead and stop the video. Okay, so we are going to use the information that we are given here, and we're going to find the approximate value of sine over 30 or sine 36 degrees. And so we see that we have sine 36 degrees. We can remember that sine, that the our little way to remember it is sine is opposite over hypotenuse, and so we'll look at from the perspective of this angle right here, the opposite is 52.9 over the hypotenuse, which is 90, and getting our calculator out. 9 divided by 90, and we will have 0.58. Now, don't let this bother you. For those of you who want units, there aren't units here. And so this is, so 0.58 is the correct answer. Okay? All right, let's go ahead and look at the next one. So go ahead, and if you want to try this one on your own, go ahead and start to work it, and we'll come back. Okay, so hopefully you gave this one a shot, and one of the things that you noticed was that there's not anything drawn on here, and the book is going to do this to you. You are going to get problems that are like this, and so I want you to remember to step back from the problem and look and see, what do I have? Well, I've got a right triangle, and I've got one of these degrees is 60 degrees. Oh, hold it. So if that's 60, that's 90. Oh, this is a 60, 90, 30 triangle, because I remember that special triangle. So 60, 90, 30. And if I don't remember that, I can remember 60 and 90 is 150, so 30 degrees has to be the difference of 180. So this is a special triangle. It's 30, 60, 90. So given this, that it's a special triangle, and remembering that in the notes, I encourage you to write in preparation for your test and to hold on to it. Copy those special triangles, that you have these already in your notes, and you will identify that this is a 30, 60, 90 triangle, and that with a 30, 60, 90 triangle, we remember that the short side value is 1, the long side, or the hypotenuse value, is 2, and the long leg value is the square root of 3. Knowing this information, we can go back and using SOHCAHTOA, or using sine over, or sine opposite over hypotenuse, we can figure out what this is. So let's go ahead, and if you want to try to pause the video and give it a shot, you can. And if not, let's just go ahead and we'll figure it out. So when we're looking for sine over hypotenuse, remember all we're doing, and it's asking for the sine of 60, so we're standing right here, and this is our perspective. We're looking for the opposite, which in this case is square root of 3 over the, so opposite over the hypotenuse, which is 2. No big deal. Square root of 3, we know that that actually has a numerical value to it. And so let's just go ahead then and go square root of 3. And you probably have this written down on your paper already somewhere. But again, I would encourage you, so you don't have to find the square root of 2 and square root of 3 constantly. And 1.73 over 2. But I don't mind redoing it because it might not be in the other videos if you haven't watched those, so that's why I kind of redo it on these. And 1.73 divided by 2 equals 0.866. There you go. And again, no value or no unit is attached to that. Okay, so remember, they're going to give you a problem like this. So given a right triangle, find the sine of 60. You've got to be able to put all the pieces together from what you've learned, and remember some of the references that you have that are going to hopefully be on your test, or on the sheet that you got preparing for the test. All right, let's go ahead and move off of sine, and let's look at cosine. It's going to be very similar. Once you get one of these down, you can get the rest of them pretty much. So with cosine A, we're going to be, so this is cosine, it is abbreviated COS, and the cosine is, if you're looking from the angle perspective of A, it's a side adjacent to A, and so that's got to be right here, because the other one's the hypotenuse, so it's the angle adjacent. In this case, it's B, and then over the hypotenuse, which is right here, and so over C. And so cosine B is no different, just it depends on the angle that you're looking at it from. In this case, cosine B, we're looking at it from this angle, and we're looking at the side adjacent to B, which has got to be A, and over the hypotenuse, which is C. Cosine in the SOHCAHTOA is the cosine adjacent over hypotenuse, so CAH, And again, cosine SOHCAHTOA is adjacent over hypotenuse, CAH. So SOHCAHTOA, and this is adjacent over hypotenuse. All right, let's put this to some practical application. We're going to find the cosine of 36 degrees. Sorry that the degree sign didn't pop up on there. We'll add it there. And so knowing the rule now for cosine, if you want to go ahead and try this one yourself. Okay, so remember cosine cos stands for adjacent over hypotenuse. And so we're going to take from our perspective standing on this angle, we're going to look at the adjacent, which is 65, over the hypotenuse, which is 80.2. And we'll come up with a value (65 divided by 80.2), and that equals 0.81. Okay, and that is how to do cosine. Now again, once you get one of them, sine, cosine, and then the next one is tangent, the last one is tangent, then you'll be able to do them all. And so this trigonometric ratio tangent is abbreviated TAN, and again it's looking at it from tangent A, so from the perspective of A, of angle A right here, it is the side opposite of, oh, sorry about that. It is so tangent A standing from here, it's a side opposite angle A, and so that's going to be here, and it's looking at the side, so that's A, and the side adjacent to angle A, which is here, so that's going to be B. All right, no hypotenuse in this. All right, so same thing for tangent B. If we're looking at it, remember that changes the perspective, the view that we're looking at it from. So from angle B, big B, tangent B, it is opposite, the side that's opposite angle B, so it's going to be little b, and side adjacent to B, which is going to be next to it, which is going to be A. Again, no hypotenuse because of the abbreviation and the way that we remember SOHCAHTOA. So TOA is the tangent with the opposite angle over adjacent. So TOA, tangent, opposite over adjacent. And so tangent, opposite over adjacent. So you can remember that way. All right, let's put this into practical application. And again, it didn't put my degrees. There we go. All right, so find the tangent of 33 degrees, of angle 33 degrees. And so I'm going to pause the video. You can try this one on your own. I bet you all have it now. Okay, great. Let's go ahead then, and we remember our rule. TOA stands for opposite over adjacent. So looking from this angle, we look at our opposite, 13.7, and that's our opposite over our adjacent, which is 21.1. And when we have our opposite over adjacent, and we do the calculation here, and we do 13.7 divided by 21.1, and we come up with 0.65. And again, even though they have units in feet up here, what you're finding when you're finding sine, cosine, or tangent does not have a unit, so it's just 0.65 is the answer. Okay, hopefully all of that made sense, and if not, go back and watch the video and rewatch the video, and that is the end of this video.